Hi, Bruno. Bruno Borges. You are still principal developer advocate for Java at Microsoft?
Hey, Adam. Yes, I am. I guess I am. Last time I checked on the HR website, it still said that. So maybe I should check again.
Yeah.
Just to be sure.
Yeah. So usually I start my guess, how they found the first keyboard and wrote the first Hello World, but we did it already in the previous podcast. And so I have actually a concrete topic. And what I did, I recorded a podcast with Ondro from Payara, and we tried to discuss serverless and war. We had both very similar idea. I edited the podcast, but I found I didn't. It was not very clear actually my idea. So this time, what I plan to do is, I would like to explain you step by step what I'm thinking about Java EE Cloud and Cloud Native, and you can ask questions, or if you find something which is not reasonable, let's do this. And because I have concrete ideas how, for instance, MicroProfile or Java EE could be plugged into a Azure cloud, and we can take an example, very simple one, like for instance is Azure Storage Java SDK, which is basically a one method call which stores blobs in Azure. Does it sound right for you?
It does, and I'm just to confirm, you're going to show me code?
No, because the listeners have also no chance to see the code. But I will read the code if necessary.
Okay.
So
That'll be fun.
Yeah, you are a hacker because you already edited Docker containers and everything. So I think there should be no trouble. So
yeah, no worries. No, absolutely. Let's dive into it.
Okay. So about Java EE. So I actually don't know. Were you somehow related to Java EE at your Oracle time or not? Or were you just, so like general advocate?
I worked closely to the Java EE team at Oracle. Yes,
okay.
In the past. Few things that I did were more on the community outreach of Java EE, like the Java EE handle on Twitter.
Java
_EE. That was my thing. Also, if you've seen these Java EE logos floating around on the internet, I will not say who did it because
cool.
Somebody did it.
Yeah, this is AI, or not artificial RI, real intelligence, right?
Exactly. So, yes. Let's go with that.
No.
So that was the most of the work. I've been give a platform for the Java EE community outreach, and as an advocate as well, of course. But my actual work at that time was working with customers, WebLogic customers, and helping them take advantage of the Java EE platform the best way possible, take advantage of WebLogic, and looking forward for the at that time, I think it was Java EE 7 release that WebLogic got support. So I helped customers take advantage of that.
Okay, so perfect. So now I explain you about my world because I have sometimes the feeling that we live in a parallel universe. I mean, we as like Java EE developers, and what I see and hear at conferences and sometimes even from the vendors, it does not reflect the reality. So I think starting with Java EE 5, so I would say Java EE 5 killed the remote EJBs. So with with the sudden death of remote EJBs, because it's the whole JAX-RS and HTTP and JSON revolution, there was no more need for clustering because the whole EJB clustering worked with remote smart stubs. So basically, since I would say 2006, there was no more clustering in Java EE. So we considered the containers as processes, let's say. And what also happened, as you probably know, the Java EE servers became leaner and leaner. So there was a lot of reasons to put multiple applications on one application server. I'm telling you this because I read lots of articles like application servers are dead, and application servers do not support microservices very well. And I think the reason is because some architects or developers are thinking that when we Java EE developers talking about microservices, they think that the application server is the cloud where we deploy several things, which wasn't the case for, I would say, 13 years. So this is history. So it was the case at the machine actually, E10K from Sun, the expensive, nice-looking machine.
Yep.
Yeah. This is how the whole shared deployment started and was actually justified by high hardware costs. But I would say since 2006, most of my clients I work with moved away from the shared deployment model because there was no business reasons for that. So what it basically means is I misuse the application servers as a very convenient way to implement business logic. So because I had lots of trouble in projects, with external libraries, and there was always forgotten libraries laying around, and references to no more existing open source projects, and my clients stuck with it and caused some troubles. Usually, if they upgraded the hardware became more concurrent, and the application stopped working. So, and what happened then is we say, okay, we have Java and we have Java EE, so let's stick with it and let's see what we can do by constraining ourselves just by using what's inside. And this works surprisingly well. I would say, like, for last 7 years we just do this, and then microservices came out, and this actually is what we always did: one process, one war, and could be considered as microservice. So instead of using the application server as a cloud, we are using a microservice as a process, like Node.js, let's say, so very similar, because it's a thin, and we put the business logic inside. And why we put the business logic? Because we get the separation. So we have the war, which is very thin, and we have the application server, which handles, the API implementations and threading and stuff like that. Clear so far? But make it sense?
Yeah, it does.
Oh, very good.
It's not rocket science.
No. This is boring technology. This is the point. As I like, this is just...
boring is good.
Yeah,
boring
very good.
Is reliable.
So, and of course, if you are in such environment, a two-phase commit is optional. So it doesn't make a lot of sense because you get lots of trouble. So we could use it, but just for legacy reasons, or, to support old apps. But I think we didn't use proactively two-phase commit also for 15 years or something like this. And I saw it recently in the Twitter, like, we don't need Java EE because we don't need two-phase commit. So, okay, two-phase commit. I almost forgot how it looks like, right? Except the XA exceptions, which is very funny. But, this is what actually happened. And then Docker came out. And if I saw Docker, I was like, this is unbelievable, actually, because what you can do then, and I started with it at very early Docker versions, I think 0.4 or 0.6 on my server. So I say, okay, this is even better because I can immutable infrastructure, right? So I can freeze the whole application server in a Docker layer and just deploy the thin war, how I call that, just the business logic to Docker. So the idea is, because the application servers, we get, I would say, every 3 months a new version. There is no need to redeploy the application server over and over again, which is very convenient because makes the whole thing faster. So we put, I put, and lots of developers did it as well, we put the application server in a layer. And because of the deployment model, we were able, to put the war and ship it first to Docker, then to Docker registry, and later to the cloud. No rocket science still, but you got the idea, right?
Yeah, I think once we start treating application servers as just runtime stack, we start seeing Java EE platform just as we see Node.js, just as we see Java SE, just as we see Ruby, Python, Perl, or any other language or platform that requires a runtime available for you to run your application, right? So once we ship Java EE as a Docker image or as a base image or layer for Java applications, it's not more a discussion about if it makes sense or not. It's a discussion of, how can you modernize your existing code without going wild with application servers and shared deployments, as you mentioned before. And I think Docker has enabled us to modernize Java EE deployment approaches without actually modernizing Java EE itself, which is beautiful from that point of view.
Yeah, it was accidental improvement, but
exactly.
But it was really an accident, but it changed everything. Actually, I think without Docker, it could be that the application server would be not that reasonable anymore, because then fat jars or Uber jars would make sense. But with the Docker layering, this Docker layering fits beautifully with application servers.
It so much does. I mean,
not almost. It really does.
Yeah, of course. I mean, on Microsoft Azure, we have a service called App Service, where you can just bring your code, your application, whether it's a WAR, a jar, whatever.
Yeah.
And we provide runtimes. Yeah, we have the runtime number one. It's the Java VM. Right, Java SE runtime. So for that, you bring an Uber jar. There is a second runtime that is Tomcat. So you just bring a regular web application.
We will talk about that. So what I would like to do with you is to extend your Tomcat runtime a little bit and have some brainstorming. What we could very easily do.
Let's go with that. Yeah.
But what you put very well is that the Java EE servers, no one cares about the servers. We only use a runtime, which happens to be called Java EE, and we're using it for productivity. And because we would like to focus ourselves just on the business logic, and we actually don't care how the business logic is implemented. And I think this is this misunderstanding, because I think there are people outside still there who believe that like the application servers are dead because they are still treated as, servers with shared deployment, which is no more the case. It's just like, Java is not dead because applets are dead. Java moved on, and now we have Java on the server, So this is like, yes, Java started to be on set-top boxes, but it happened to be, it was not very popular. And now we have Java on server. And the same is with application servers. The actual idea was shared deployment to save money on hardware. But right now, we have the hardware is cheap, but because of Docker, accidentally, we got another perfect use case, killer use case for deployment model, right? So, and therefore, what I never got, the idea of the whole MicroProfile thorntails and swarms, because what they do, they try to package everything in one jar, and it is harder to use, the Docker layering as a feature. So it's harder to establish so-called immutable infrastructure, where you just shipping what changes and everything else is frozen, right?
It's
just logical. I mean, what's popular or not is just doesn't matter. It's from developer to developer, and you don't have to speak as a Azure advocate. It's just from your experience as very young, gifted designer with Java EE logo background, right?
Yeah.
Got it?
I think I did.
Perfect.
I think I did.
Perfect. So now this is the boring stuff. So what do we get then? We have a war, and we can push the war to the layer, and then we get JAX-RS endpoint and dependency injection, and we can inject JPA, and if we like, sometimes JMS, and this is basically it. So what do you get? You get, I would say, a pretty boring set of APIs, which are very common, and you can build your own API, but you are still not using, cloud-specific features, right? So you could just run something in the cloud. You could use Java as a programming model, which basically is very nice with CDI and JAX-RS. Is really very productive. And it's even more productive than Java SE because with Java EE, something like, configuration or interfaces are exception from the rule. Usually you just inject, with 3 classes, you can build a nice CRUD service, create, read, update, delete, or even with 2 classes. And this is what I'm talking about. Okay, perfect. Now, we can get a step further. And I tried before. So what you actually can do, you can say, hey, I'm Microsoft Azure, and we could, choose application servers or one application server. It does not matter, and we could actually create an image with, let's say, Tommy, because you mentioned Tomcat, or Payara, or Open Liberty, or whatever you like, and this image is already in our private registry, Docker registry. And then what will mean? We only would need somehow a protocol. Let's say let's do FTP. This is crazy, but no, not FTP. Just go HTTP post. So what I would do, I would say curl upload my war to your cloud, and what your cloud will do, Docker build. It will take about 1 second and start the server. And then this would be like a minor extension, because then what happens then? We are almost in serverless, right? Because what happened now, my war is just business logic there. I have just 2 dependencies to Java 8 and to MicroProfile, and I actually don't know what the runtime is. I don't care about that. I push it just to the Microsoft Azure cloud via curl post, and which then a hook wakes up and says Docker build, and then runs the Docker container. So this would work with, I would say, this would be a prototype which will take, let's say, I don't know, 2 days, 3 days, no more. And what are the benefits? The benefits is I could actually locally pick whatever server I like and push it, 60 times a day to the cloud, or 100 times a day, because the war is very small. It would be very quick, and the productivity would be great. So this is the first idea. What do you think about it?
You don't even need to exactly build the Docker image locally and ship the Docker image, right?
No, in the cloud. You should build it in your cloud. I would just ship my war, which would trigger an event, and then you will build the image for me and start the server. And this would be, this would be like, lambdas on steroids, because I don't have to care about all the, strange programming model. I would just implement my application, what I did, as I said, 2 classes for CRUD, and now we are talking, right? It will be hyper productivity, and I get all the metrics, Prometheus, and all the stuff for free.
Yeah, and that's exactly what we do. I mean, in our cloud right now, on Azure, that's exactly what we do in one of the services. You ship your WAR file, and we package that inside a Docker image, whether it's a Tomcat or a Wildfly. We now have support for Wildfly runtime. So you can have a full-fledged Java EE stack runtime.
And this is already, I didn't know about Wildfly, but this is already very interesting, because now it is actually a serverless environment, right? It is.
It depends how you define serverless.
Okay.
If you define serverless simply by something that you don't have to set up and manage the infrastructure yourself,
yes,
then yes, it is serverless-ish. But in cloud computing in general, and how the market has accepted the term serverless goes beyond that, because if only by that we understand a serverless, then almost anything in the cloud can be called serverless, which is not entirely true. We could say Terraform and Chef provide a serverless-ish environment where you just trigger a command and infrastructure is set up magically for you, which is it's serverless from that aspect where you don't set up the infrastructure and have to manage it. It's all automated with your own scripts once you write them, or from companies that you acquire those scripts from. But serverless goes beyond.
Okay.
Serverless.
What is lacking is the orchestration of the images, right? So I don't like to have one Wi-Fi running. So I would expect later V2 that you have Kubernetes set up. And for instance, you could just start and stop or just watch my pods running. And in every pod, there is a Wi-Fi, for instance.
Yeah. That can be achieved today, right?
Yeah, but this is really serverless, right? Because you could even behave like Lambda functions. You can say, look, demand is so high or nothing happens in the app. So I will hibernate the whole thing. It's not a problem, right? There will be actually no conceptual difference to AWS Lambda, right?
So yeah, if we extrapolate the serverless concept and we take into consideration that, like for example, the Kubernetes cluster, we are only paying for the manager pod, the control plane, right? Mm-hmm. If that is the only thing that we are sort of paying for, and everything else, we have an automated scheduler that goes up and down with pods, then sure, that is some sort of serverless approach. But it's still up to the customer to manage that cluster or that Kubernetes installation or just cluster.
But I don't think...
And all the automation of the scheduler also needs to be managed by the customer. So that's where the serverless terminology gets blurry.
Yeah, but I think we could just hide that, right? So what we could do, we could provide an XML, not a YAML configuration, because YAML wouldn't be serverless. So let's say XML, XML configuration, and say, I would like to have... I
like XMLs.
Yeah, I also like XML. I get so many errors this week with YAML, so I'm really happy about XML, and yeah. So and just imagine, version 1. I would just have an XML file which states number of pods 2, and that's basically is. And it's done, and there should be 2, and you need just HA proxy, and I don't care about anything else. And then of course
So I just want. I mean, I like the idea of calling this a serverless thing. But if we call this serverless, how can I say this? I think we are extrapolating the definition of serverless to fit or to be able to wrap an idea or a concept or something that can be technically done, but actually isn't like that. I think Java EE as a runtime has still a lot of value. It provides everything that most business applications will ever require. And shipping that runtime in a Docker container, being able to have this base layer where developers can simply ship a WAR file, and that WAR file will be picked up by some automation system that will throw that WAR file into a new Docker image that has the base layer as a Java EE runtime, and then scheduling that to a pod on a Kubernetes cluster and running the application for as long as it needs, and then shutting down that pod to save or reduce costs. This flow, in a sense, it can be called serverless, but the one piece that is missing is that serverless the serverless approach is event driven in the cloud.
Mm-hmm.
And that's where we don't have yet, and hopefully that will change with projects like Knative and how that can be matched up with this idea of Java EE as a runtime Docker containers in Kubernetes clusters, combined to provide the actual serverless approach, but still releasing business code using Java EE. I think that is promising, and I think many people, many developers will find interesting ways to combine Knative with any sort of runtime that, for example, could be a Java EE image.
Yeah, sure. I'm just, speaking from my Java EE experience because I wanted to talk with you about that because as the serverless discussion came out, I tried to find the definition. I think, wait a second, what I'm doing right now is the whole time serverless because we don't care about the application server for years anymore. We just, push them to a Docker container and they could actually stay in the cloud. So I really don't care. And regarding events, I mean, what we can, of course, do is, I also don't see any conceptual difference between a message-driven bean listening to a queue and a Lambda function, for instance, right?
Yeah, in a sense, yeah.
Yeah, it is identical. I mean, and from the programming perspective, message-driven beans are actually very, very lean. But it's interesting. I would say it is absolutely serverless. The thing with the events, this is what's an interesting topic. So I would consider the JAX-RS endpoint and HTTP as events because events will trigger this. And what we could do, we could say there is no request response. What we only allow is, for instance, an asynchronous post or something like this, and then we get our events, right?
Yes, but JAX-RS endpoints to be event triggers or to be trigged, they have to be always running, right? So you will need a Java EE application, even if a small one, with your JAX-RS endpoints always running to receive the HTTP request as event triggers for your subsequent pieces of your system. So that's where I say the serverless definition is blurry. The value is still there in terms of developer experience. The value is still there in terms of deployment agility. So as long developers are comfortable with that, and they can take advantage of a Kubernetes cluster and the automation and CI/CD and being able to come up with a serverless developer experience, not necessarily a serverless economical model, that has its own value already, and developers should be looking into that for sure.
Mm-hmm. But I don't know whether you are aware of the FN project, the open source GitHub project started by Oracle 2 years ago.
Yeah, I'm aware.
Yeah. So I played with it and implemented some functions. And the whole deployment model with Maven, at the end of the day, it is not that different. Even the size of the Docker image is not that different to a Java EE server. And the functions, either they are regular functions, and HTTP they are called hot functions, so they are running for longer. And if you hit the function which is cold, it will start the function. So in such a Java EE environment, what we still will need is a kind of a queue before, which could be provided by the cloud provider, right? So I would expect to have like a queue, an Azure queue and queuing system, which buffers the events and then dispatches the events to the JAX-RS, JAX-RS endpoints. I think this could be done as well, right? Then we are really serverless.
That is But that thing where cloud provider manages the triggers or has the triggers always running somewhere, that is a serverless economical model, right? That's where that's what I was talking about before, where someone else is running your event listeners, but it's not the customer that's paying for that. If that is achieved, as in many cloud vendors such as Amazon, Google, Microsoft, and Oracle with its cloud function service now, that's a great advantage. So if customers can take advantage of the serverless environment that the cloud provider gives and still can use existing programming models, that's a great capability of that cloud vendor and of the underlying platform, whatever that is.
Exactly. This is what I'm talking about. That just, use the best thing from the cloud and don't give up your programming model.
Right. Yeah. That's something that should be really considered, because one thing that developers should be worried about serverless is that most serverless platforms kind of give a lock-in to the serverless environment. Mm-hmm. So being able to externalize your business code in a platform that you can easily move to somewhere else, whether it's serverless or not in the future, I think that's important. And that's why being able to ship functions as a Docker image, it's an interesting approach. Mm-hmm. Projects like the FN project or OpenFast are great examples. Azure Functions on Microsoft side, the one advantage is its support for on-premise execution. So you can take Azure Functions, because it's an open source project, and run whatever you want, even if you decide to not use Azure Functions anymore. The service in the cloud, of course. Mm-hmm. There are some work done with projects like Spring Cloud Functions that abstracts the programming model and allows you to write Spring code. And I think it's a matter of time that somebody exposes the programming model of specific clouds in a way that it allows developers to write Java EE code instead. And that code will still work fine in those serverless platforms. I think that is something that could happen if there is enough interest from users and developers. But until then, just being able to ship functions as a Docker image, and inside you have your Java EE runtime with your business logic written in a programming model that is not locked in, I think that's a great advantage.
Mm-hmm. And what also happens is the serverless is always somehow bound to function as a service. So if someone, it doesn't have to be that way. So as we now evaluated with the war and Java, but usually for unknown reasons, if someone mentions serverless, usually what they are thinking about is function as a service. And the function as a service, there are some, killer features. Like, for instance, they can use them, like, for instance, message-driven bean, and listen to the queue. If there is something on the queue, wake up and process this. This is great. But at the same time, I cannot imagine to build a mid-range applications just with functions. So we had this in Java, let's say 5 to 10 years ago. There was at least in Europe, we had a wave of command patterns hysteria. We say, okay, everything has to be a command pattern. Then everything is generic and replaceable. And this was a mess because no one knew what actually going on. The generic input parameters and output parameters were passed back and forth, and the system was not even distributed. So the whole communication was without any reason inside the applications, and hoping then one day a command is going to be replaced, which actually never happened. And then it became even worse with JMS. In one point of time, everything had to be a message. message-oriented middleware to have scalability and modularity. And what happened then is such applications were really hard to debug, and the robustness was terrible, because if you put something wrong in the queue, everything blew up. So and functions are not that different. So I think having a programming model, a Corsair programming model, not just input output, rather than what we are talking about in Java EE. So you get facets, which are a lot easier to program for simpler use cases.
It depends. Yeah, it really depends on the application, right? Where serverless will thrive, in my opinion, is event.
Yes.
Event response.
Absolutely.
Event policy. That's where serverless is really going to thrive. Any other use of serverless that is not for events, and by event, I don't even say HTTP events, because HTTP events are they are fine for some use cases, but on average, you don't really want to use HTTP as event processing communication protocol.
No.
You should be looking at binary events,
yes,
like storage events, or event systems like Kafka streams. Those are the sort of events that we should be really looking at when we develop serverless functions and integrate those into our larger systems. If those are the scenarios, then serverless platforms that allow for quick execution of the function, low overhead, low memory consumption, fast scalability. How do we go from one instance of the serverless function to thousands of instances of the serverless function? Those are the main values that we should put into consideration when choosing which serverless platform to use or which approach to take. But regardless of that, just being thoughtful on the programming models, I think it's important that serverless functions allow developers to write functions on any language, or to a certain degree, of course, cannot support 100% of all languages in the world, but being able to allow developers to use their existing knowledge, whether it's a programming language, whether it's a framework, I think that provides a lot of value.
Yeah, absolutely. But what I see in the wild, in the projects, that happened several times to me. So last year, there were two startups. They thought, they can do everything with a function. And it is like, I don't know, it seems almost like, hidden knowledge. We are a startup, so we have to use functions for everything. And this is, from my perspective, unmanageable. And what I presented them was of course, right, Java EE server, and they had no idea what Java actually is. And they were delighted. It's like, and will it run in the cloud? Like, sure, we can just, what I said right now, we can push the Docker and now to the cloud, and now they are running Java EE and very happy. And we have our view functions, which are consuming the events and translating them and invoking the application server. And this is a very productive model. And it works extremely well, I would say. That well that I get asked by the startups, why it is so great. It's like, this is old, boring technology. No one is excited anymore by Java EE, so we have it for years. It's like almost like secret weapon or forgotten wisdom, which is really funny for me, watching this right now, because it's a revival of the old stuff. And
yeah, no, that's that's one of the reasons I like the MicroProfile project on Eclipse Foundation, because two things happen. Two things I see happening with MicroProfile that maybe nobody is noticing or not talking about it widely. One is that MicroProfile takes away the idea of application servers, right? MicroProfile does not talk about application servers at all. It's just like, neither did Java EE in the past, but Java EE and how people perceive technology is one of the things that drive the adoption, frustration, or disconsideration of for a certain technology. So the perception is really important when we talk about technology. And Java EE came to a point where it achieved a level of disgruntledness that developers don't feel like they can trust the platform or invest in the platform anymore for new projects. It's old, it's legacy, it's application server, it's not cloud native. That's the perception. Whether it's technically possible or not to do new things with that platform, that's irrelevant once the perception that it technology gives is not what people would expect. So that's why MicroProfile is interesting to a point where it's the same programming model, it's the same set of APIs. It goes a bit beyond at certain points in some APIs, has a completely new name, and it does not talk at all about Java EE application servers, or has no notion about application servers. That is where I would say we have a chance of keeping that technology still available in the future, and that programming model available to others, and still leverage and get community developers to adopt it in new ways, such as cloud native deployment, or maybe one day serverless, and we make MicroProfile work as a first-class programming model in serverless platforms. So the idea of using runtimes that support those APIs just as a runtime stack, that is an interesting idea to a certain point. Once we are able to write code with that existing, already learned programming model, but still use automatically in different new ways, then we're going to see a lot of even more value for that platform, for that technology.
Yeah, you are absolutely right. And as the Jakarta started, they said, okay, we should rename it from servers to runtimes. And I asked them, what's the technical difference between server and runtime? And they say, actually, there is no difference. So, okay, then why renaming? But what occurred to me with discussing with you, I would say the difference is the name server implies the server runs all the time. And the runtime would mean, we can shut it down very quickly and start it. So I think it would really wise, to talk about Java runtimes and not Java servers, right?
Yeah, and I think we as engineers sometimes forget how important perception, communication, messaging, even marketing of technology is so important to keep the technology alive and well adopted, and developers happy with their choice and decision of adopting that technology for mid to long term. So if we can allow developers to use existing programming models and still be excited about the technology, how we make that technology perceived by existing and new developers is extremely important. If we go completely away from the idea of servers and we focus on the runtime approach, on the runtime message, then we can actually make people think differently on new use cases, on how to use that thing, just because we are communicating in a different way. So Java EE APIs and programming models as a serverless approach, I think that is an interesting idea. It works today, as you have shown. We just need to make that perhaps mainstream. And to do that, we need to communicate better. And
yes, absolutely.
Better, we need to use better terminologies.
Yeah. And so my criticism a bit about MicroProfile. So what I really appreciate MicroProfile, I use it all the time in all my projects because of, I would say, a great stunt, which I completely overlooked. So I was actually against MicroProfile at the beginning because they started with own runtimes without a reason. But then what they did, all major application servers are supporting Java E8 and MicroProfile. So what I can do right now, I can just use MicroProfile in all my projects without asking for permission. It's just there, which is really great. And what MicroProfile released like a starter kit and also bombs, and it implies that you don't need to know the full MicroProfile. You can pick and choose your APIs, and this is, of course, nice, and developers like it. Is very good for marketing. But what I think is more important, to have opinionated runtime, which would mean it say, look, there is a MicroProfile 2.2, and you get everything. It is very small. This is what Rails did back then, and not what we did, with OSGI or Eclipse, where you had 500 plugins and no one knew, which plugin to take, and or even what Visual Studio Code does, right? If you download Visual Studio Code, it is usable from the beginning. It's a great editing experience for everything. And if you would like to have, specific things, then you will have to install, Java plugin or whatever. But for the mainstream HTML, CSS, and JavaScript, it just works out of the box. And this is why it's popular. I would say if Microsoft would ship, empty shell and say this is lean and just pick your stuff, it will never fly. And this is the same with MicroProfile. I would say, look, this is all APIs are there. You can rely on the existence of the APIs. I think this is very important for business apps. And this opinionated thing, this is what I really liked in Java, the convention of a configuration plus opinionated way, which was somehow stolen from Rails also 15 years ago. But but this is actually what made me excited about the whole Java thing. It's like, don't make me think. Just focus on business, self-constraining, and go ahead and forget all the frameworks left and right. And this is why I still enjoy coding, I guess.
Yeah, it's I think every framework these days, every platform, every runtime is opinionated to a certain point, right? There's no more. I think we came to a point in the industry where there's no such thing as standards per se. Everybody's creating their own framework. Everybody's creating their own file format. Everybody's creating their own network protocol, right? I mean, Google has been investing a lot on network protocols of their own. Developers are writing JavaScript frameworks every day. People are creating file formats for data transfer or configuration files in different ways. Everything is becoming opinionated. Everything's becoming the way everything's becoming whatever the developers want to be and however they want it to be. And that's not a bad thing per se. I think it just gives opportunity for everybody to come up with their own solutions. But at the same time, it makes it harder for people to come into the industry as like newcomers. Which language to choose, which framework to choose, which file to choose, which protocol to choose. Because standards are still there. We have standards in networking. We have standards in file formats, driven by governance bodies, by foundations, and so on. But when it comes to innovation, when it comes to moving fast, and just being able to build things however we want, we achieved this point where there's no more actual standard, and developers are free to choose. So that's why platforms and cloud services, environments that allow developers to run whatever they want are so important, especially in the cloud. And being able to ship and run whatever you want, however you want, is the ultimate application server. So Kubernetes and containers are the de facto application server and deployment unit or packaging unit. Because that allows developers to use literally whatever they want, however they want.
And now a short story to you. So I work with lots of developers in Kubernetes and Docker environments, not Asia, but and they are Java E and Java developers. And what happens is they are absolutely not interested in the Kubernetes stuff. And what they do is they build locally, with Docker Compose and shell scripts, whatever. They try to create their own environment, not to use Kubernetes and YAML and whatever. And they are not even satisfied with OpenShift, which is a nice environment. They just don't like to do this. So they like Docker and nothing else. So I think there's also great misunderstanding. It's just here at conferences Kubernetes, and actually, I never met a developer who really likes Kubernetes. So this is like they try. Okay, literally in every project so far, I force developers to delete their Docker Compose stuff locally and use the cloud more, because I was in projects where they never managed to deploy it at the end of the cloud because they use Docker with, without the security, how it's called, with the user. With user roles and writing to our wrong directories, and it actually was impossible or really hard to deploy to the actual cloud. So I think simplifying the whole thing, we talk about it already, but this is probably interesting feedback also to you, that the developers are actually, or in my world, even not that interested in the whole Kubernetes, because it's way too complicated. So you have to learn, lots of stuff without any business value.
Yeah, absolutely. I mean, Kubernetes is not supposed to be something that developers should be touching. Yes. Just as Java EE application servers were not supposed to be touched by developers, right?
Exactly.
It's the notion of an application server, whether it's Java EE application server or whether it's Kubernetes, I think it remains the same, right? Yeah. Kubernetes is a little bit far behind in some areas compared to traditional Java EE application servers, but it's well ahead in others. Well, number one, it's polyglot. That tells a lot by definition. But if developers only consider the boundaries of, here's my application, ship it. I don't care how you run it. I don't care where you run it. I don't care if you're gonna run it forever. I don't care if you're gonna run just triggered by events. If that is something that can be achieved one day, that's wonderful. And I think we are not far from that model. But there is a lot of work to make the whole environment consistent across different programming languages and different frameworks, and that's where event systems become so important, because if anything can be translated into an event, even an HTTP request, if we could translate an HTTP request into an event, say in Kafka, that sends that event to Kafka, we have a function that is triggered because of that event, processes a request, sends it back, and it goes back as an HTTP response. If everything comes down to cloud events, which is an attempt to make a standard around event systems in the cloud, I think we're gonna see the industry moving really quick, really fast, and in a way that nobody ever expected.
Mm-hmm. Yeah, cloud events are really interested. I wanted already mentioned it. So this is what MicroProfile could provide one time, binding to cloud events, right? This would be an interesting extension from MicroProfile. And for instance, this I would see in MicroProfile, not in Java itself, because until Java includes, or Jakarta includes this in the spec, we will get 4 iterations with MicroProfile, so less formal process.
Yeah, right. Cloud events is an interesting standard, which, by the way, is driven mostly by an architect at Microsoft. Mm-hmm. And if we get to a point where system can be reduced to work with events in that way, for every single aspect of communication between the application and or applications, or between the application and the user, then we will start seeing interesting things in how we program systems, programming models, and deployment options. And I think we're going to perhaps start seeing a normalization or a standardization of how we write software. Maybe one day we get to even to a point where we don't see new frameworks popping up every week, regardless of language, and we start stabilizing the industry. So hopefully cloud events and event systems will help us in that journey.
Now, the last idea is to extend, to augment Java EE with Asia-specific services. So far, we just have plain Java EE container without any added value from Asia, from Microsoft Asia. So, and I just took a brief look at the Asia storage. This is like API, which comes with a nice single Maven dependency, Asia storage blob 10.5.0, and you are set. And the code example. So in order to get the reference to the blob, you need the account name and an account key, which is normal. You will have to create a shared key credential, then create a pipeline, an HTTP pipeline, a URL, service URL, and then you get the blob URL. And such the bootstrap is remarkably similar in all clouds. So you always need the credentials, and you get a reference, or you will have to create a singleton and fetch the service, and then you are programming against a nice Java API. But what I would do is I would delete the first, let's say, 10 lines, the whole initialization logic, and make it injectable. So how to achieve that? So actually, we could wrap this Microsoft Asia and blob in a small CDI module with a producer, which produces the final API, which is called blob URL or container URL, and then you only will have to say add inject blob URL. The shared credentials and the service names could be derived from conventions, because you already have the image which was created by me, so we can just instantiate that, and this will simplify a lot. And I didn't saw any example in all the clouds, and I said this is unbelievable, because mixing our thin wars idea with that, this would be like ultra productive environment. I would just inject, your block storage, your data lake, whatever you have, with add inject interface. I don't have to include the SDK to my code, because you already have it. So, and this would be, of course, completely proprietary, but I wouldn't care. So my war will be still empty. I only have the Cloud Asia API. The implementation is on the server, and this would be extremely good developer experience comparing it to now, right? You know what I mean?
I think I know what you mean. A lot can be achieved, right? It's given the option to the developer to just access the service without having to establish connections and save credentials, hard-coded or whatnot. Just use the connection, and that's all automatically binded into the application. That's super powerful in any kind of system, in any kind of application that developers have to write. One capability that we see growing fast is application principles, where instead of putting username and password inside code or inside environment variables, we create a principle for an application that gives a token that will allow that application to establish connection to the cloud service. Mm-hmm. That token goes into the environment variable, and that token is valid as long as whoever manages the service allows that token to be valid. You can even set policies to expire the token from time to time. So that's also a powerful approach for for connecting services to applications. The other option that we see quite often being used is what we call message service identity or managed service identity. That basically means that once your application is running in a service, at least on our case on Azure, we will inject a principal credential automatically on that application that will allow that application to talk to this or that service.
This is what I'm talking about. So if you give me, the token in environment entry, I could just initialize whatever I need behind the scenes and inject the final result, which in the case of the blob service is the container URL, and this is super lean. So I could hide, the whole bootstrap initialization, which comprises, I would say, 10 lines of code, and hide it in a Docker layer, which is already prepared. And I only use a nice programming model, which is with @inject, and I could specify my configuration somewhere, so we can use Builder or whatever. And this would be greatly streamlined. This would be actually competitive advantage because it would be really easy, to use all the Azure services in a unified way.
Yeah, and one of the work that our engineering team is working on is to allow MSI to work with any Azure SDK and any language. So let's say you want to connect to Cosmos DB or SQL Server or whatnot. All these libraries, these SDKs and libraries would automatically pick up the MSI in the environment if the MSI is available and authenticate using that token. And that's automatically binded by the platform under whoever owns the subscription of that application instance. And this facilitates a lot the developer job in deploying the application without much configuration. It will just assume that once the application is deployed in the cloud, the application will connect to the cloud database, to the cloud storage or whatever. And that information is given and granted once the application is in the cloud. That's a powerful model. And I think right now, I don't see that model being taken advantage of by MicroProfile or Jakarta E, but it's something that definitely should be looked into, especially the security API that came recently together with the configuration API. I think those two combined can give the users and developers that capability quite quickly.
Yeah. You just talking, just about the security, and I'm talking about, streamlining the whole initialization of all the APIs by doing this behind the scenes and just injecting to the application the final result. So let's say we have the Java 8 API, and we could got, the Microsoft Azure API, which comprises all the APIs which are injectable. And then this is what I'm talking about.
It's for MicroProfile, we have a proof of concept that it's available on our GitHub.
Cool.
For I think Key Vault. I think it's Key Vault, where you just put the Java dependency, the Maven dependency of the Azure MicroProfile Key Vault extension, and that will give you automatically the API and the binding and the injection of your Key Vault environment into your Java code.
Mm-hmm. And if we combine both, we could have really, serverless-like experience with nice access to Azure API, which would be a very productive programming model. So it's actually just syntactic sugar around, already existing APIs.
Yeah. And it's close. It's close to the notion of serverless from that perspective. People take.
Cool. So we spent now 1 hour with content without introduction. I hope it was interesting discussion. you didn't knew what to expect.
I had no idea. That was good.
Yeah, thank you. So I also was good, to hear your opinion, and the thing with the server, it was actually a good point that if we renamed the whole thing to runtime, it doesn't imply that it has to run all the time. And yeah, perfect.
Renaming is easy, right?
Yeah, it's just marketing.
But it's the first step. You cannot communicate something new if you don't rename it first.
Yeah. Perfect. Please send me the links to the if you have to the Whitefly Java endpoint, and I could play with it if
absolutely.
Get some time.
Absolutely. I'll share everything that I mentioned today. I'll share with you. Perfect.
And any final thoughts or?
Honestly, I would tell people to try out Java EE and MicroProfile applications on Azure. The reason being is that we want to enhance the support for that on Azure. And we did some work with MicroProfile specifically. And if you go to docs.microsoft.com and you search for MicroProfile, you're going to find a documentation page. And as I mentioned before, we added a Wildfly runtime image to Azure App Service so you can run fully fledged Java EE applications. I think it's, I don't know which version exactly of Wildfly is, but I think it's Java EE 7 compatible. If it's not 7, it's 8, either way. And I'll just tell people to try it out and provide feedback, whether through GitHub or over Twitter or email, however it's more convenient.
Yeah, perfect.
We really want to help developers bring their applications to the cloud, and if there's any way that we can make that experience easier and better, we'd be happy to.
Yeah, perfect. So thank you, and we should perform our cloud sync in half a year or something. Just talk again what happened in that time, if you have time.
Yep. Sounds good.
Okay.
Thank you so much, Adam.
Thank you. Bye.